Hi.
Yeah.
Question. Any idea why the translation is different but not harder than original?
I think it would be interesting to look at, if we had the data for it, to look at an even more fine-grained thing of like, well, is translationese from English or translationese from German? Are those different translationeses? Like, what is it about translationese that makes it different? Is it the fact that the original language is somehow still retained in there, perhaps in like the way you structure your sentence or some weird phrases that are too literally translated? Or is it something that translators are generally less likely to come up with very big, elaborate constructions, whereas a native speaker is going to be like, I'm going to be so fucking elaborate over here. So that would be interesting to tease apart. That's like things that I think would be possible with the data we have, because we do have the original provenance for the languages. It just means these languages are getting, like, our trained data is getting smaller and smaller and smaller. And at some point, I'm not sure if I can trust the results without that well anymore, but it would be interesting, yeah.
Do you know if maybe could be variance within human translators?
Oh, like, for sure. So that's another thing that will be interesting to look at that we do not have the data for, as far as I know. Or at least I don't have the data, is who translated this sentence.
I was like, oh, can you have that? No.
That would be nice, that would be nice. So I guess the closest to that we have is the Bibles. But those Bibles are so different in style that I feel like it's unfair to just speak of translators' differences. So it will be interesting to get the data, and I'm sure the European Parliament has it somewhere. It's just not part, as far as I know, of the Europarl data release. I don't know if the UN corpus has it, I don't think so. JW300 certainly doesn't. So that would be nice to have, but I feel like it's going to be hard to get that at like a large scale. I don't know if it could be wrong.
I might have misunderstood this because you found out that basically in your second part, you realize your language models are mostly trained on translationese because a lot of the data is translationese. Doesn't that mean that your experiments, your results in the first part is the same? Because the Europarl results, of course, I mean, because you're gonna also train on translationese mostly.
So in the first part, when we say the difficulty of a language, it really necessarily means translationese in that language and a bit of native context. So we
mix together. Yeah. Right. So it's not really that's kind of
Given that they aren't really that different in terms of raw difficulty, I think that's not. Just like, do I want to show? Oh, this one. I think that's not too bad. Even if the languages have different levels of nativeness, they're all going to be translationese dominated, right? Okay. And so once we take, sorry, this is already the parallel data set, never mind, but they're already all translationese dominated. So I don't think it's introducing any too worrisome bias in there, but it's definitely yet another confound.
I have another comment. Probably this is could be another angle to look at difficulty. Now this is something that we've done where we try to use left to right language model, generative language models, like what you do, to try to predict the fluency or acceptability of a sentence, and like as judged by a human. Okay, and what we found is that language models, particularly for some language, they predict the human sort of judge acceptably a lot easier than some other languages. For example, language models like German language models tend to predict with much higher correlation, for example, compared to English. And of course, it's not quite exactly difficulty, but I just felt like it's another angle looking at difficulty. But by looking at basically how language model predicts fluency or acceptability. And again, it's all about surprisal as well, right? The more surprised you are, the less fluent it's going to be. So I just kind of wonder, how come we have basically contradictory sort of findings, like say German and English. One thing that sort of I was thinking why could be the case is that we suddenly found this is that you really want to have a good language model. What I mean by that is that if you train a language model on like a small data set, and of course you have a language model, right? But it's not really a great language model. It's just a language model. But if you really train like big language models, and we're talking about GPT and whatnot, then the results, the patterns are a little bit different. And so I sort of wonder, because all your results are all trained using RNN on like, your PAL data set and fairly small, basically. We're not talking like web corpus or anything like that. I just slightly worry that if you sort of train it on much larger data set, whether you're going to still see the same finding or not. So that's just a side comment. Yeah.
One thing that kind of relates to both your first comment and your second one is that I'm really like for your experiments, did you also have perfectly balanced training data? Like all these models comparable and okay, so
comparable
that point,
only
like,
in the sense that they all train on Wikipedia, but of course the Wikipedia size is very different for different languages, right?
And like the style of German style Wikipedia is written in a very different way from English style Wikipedia. It's fascinating to see like the politics of Wikipedia. It's such a minefield. But yeah, so that might be one of the things. The other, I think, is totally right. It would be super interesting to also look at other downstream tasks. That's what I'm gonna call that, which is maybe not the best word to use, but it would be interesting to see, like, can we probe attributes about the language? Can we do like this morphological agreement task for languages that have agreement equally well across languages? Do they all yield equally good contextual embeddings and so on? It just gets harder because the metric isn't so innately comparable as probabilities are. So if you do something like classification, maybe that would work out well. Like I could imagine NLI being somewhat comparable. If we had translated NLI data sets, that would be interesting. That's something we could do. Definitely a good comment, I think. That yeah, difficulty is a very opinionated concept, and it's only going to get worse from here on out. So I feel like this is the one where I'm like, okay, yeah, we're kind of on board. Yeah, likelihood seems reasonable. Wait till we get to the next talk. That's going to be interesting. But yeah, great comments. Thank you for that. Anyone else?
There are a couple of comments and questions in the chat.
Okay, gotcha. What's up with average dependency length correlations? Do we know if the language is different in this dimension? Yeah, so this is again something we only were able to do for the 21 Europol languages because we needed good parsers, and we validated the UD pipe for that purpose, and it was good enough. And they were different. And again, there were correlations that were basically something like p-values of something between 0.01 and 0.05, which like would have been interesting if we hadn't corrected it to death just because we tested all these different other things. So if you want, I can also just send you those numbers. I don't remember off the top of my head what the respective averages were, but they were different enough and that these correlations were there. So I'm reasonably optimistic that a replication that would only look at that could find something. Yeah, hope that answers that question. Let me know if not. The second question, as a translator, I found that both data sets must be very high quality translations made by professionals who are taught to recreate their translation to be as close to native and natural speech as possible. So one won't call it translationese. You might see a bit clearer difference if you use less high profile translations where translators are not so aware that they must recreate rather than translate. That's an interesting comment. I would hope that the European Parliament trains and pays their translators well enough that they should be doing that. So I wonder, maybe that is also another source of like this disparity, that it's commonly said that translationese is easier, maybe because a lot of translationese doesn't come from high quality contexts. And just in this study for this European Parliament data, they did a good job, and so that's why it was equally complex. But then again, we did find a difference in them just from this first study right here. So I wonder. That's definitely an interesting comment. Yeah, I would be curious to now see like, what about like well-trained senior translator versus underpaid junior translator? That would be interesting. If only we had data for this. Yeah, thanks for that comment. Cool. So I would say, let's go on if there are no other questions.
Any other questions? Yeah, I have a quick estimate the size of the paradigms and the number of slots within the paradigm when you try to approach the morphology complexity.
Sorry, how do we count them?
Yes, how do you estimate There's a number of slots within a paradigm.
As far as I remember, we literally just took what we have in Unimorph. I'm not entirely sure though anymore. So those numbers for this paper come out of the previous paper, in which I was only a fledgling junior author, and I do not remember where we got these numbers from. But I think it was counting what is present in Unimorph.
Okay. Yeah. Any other questions?
Can I comment on something if no one else has anything to say? So I know you hated mass language models. So do we. We didn't want to do anything with mass language models when we're looking at trying to predict acceptability in language models, because you can't get proper sentence probability, for example, right? But we did it anyway. There's no real sentence probability. You can compute that. You just do your sum log prop like what you do, but you do it one word at a time. You mask one word at a time. But we found extremely surprising results. So maybe you might want to consider just testing them out and see what happens. We found that they do a lot better than left to right. No surprise, but the patterns was slightly different too. And anyway, it was something surprising that we found. Yeah.
Interesting. Yeah, I just have a hard time wrapping my head around what it really means to sum up the log probabilities. Because now, if we do different segmentations, like if I only mask out a very small segment, all of those are going to be great, and so the sum is going to be great. And I don't know.
Yeah. Intuitively, it didn't make any sense at all, but I mean, there's no technical barrier to do it, right?
Yeah.
So we do it anyway, but we found interesting results, and yeah, just thought we'd share that. Yeah.
Yeah, I wonder how that correlates. Yeah, that'll be fun.